In this video, we will we will determine the response of the first order system with unit impulse function. Response of the first order system with unit impulse function. Unit impulse function. So here our R of t, that is unit, is a impulse function, and R of s is equal to 1. So the Laplace transform of an impulse function is equal to 1. So with that, C of s is equal to 1 divided by 1 plus st, this is the first order transfer function, into 1. Now I'll divide each numerator and denominator by t. So I'll have 1 divided by t into 1 plus s plus 1 by t. Both numerator and denominator has been divided by t. So now taking inverse of this function, taking inverse, we get C of t is equal to 1 by t, this is a constant, into e to the power minus t by capital T. So this is the response of first order system for unit impulse function. So I'll just plot this curve. So this is a simple curve. You don't have to add or delete any curve here. So it's a simple curve. So this is t. This is c of t. So 1 by t e to the power minus t by t curve will be something like. So this value will be equal to 1 divided by capital T. This is 1 by t e to the power minus t by t. I will not go to find out the steady state error of this function, because r of t is an impulse function, and you cannot exactly find out the steady state error there. Okay, so because it's an impulse function which is having unity area, but very infinite height or zero width. So for such system, it's not possible to find out the steady state error. But now the next part here will be, we'll be comparing all the three responses, that is unit step response, unit ramp response, and unit impulse response. For the same system, we have analyzed with unit step input. So such response we call it as unit step response. So with that, we will start with this analysis comparison. First one is unit step response. Then we had unit ramp response. Then we have unit impulse response. So coming to unit step response, we have seen that C of t is equal to 1. Just a minute. I'll just write it in one order. Let So let this be unit ramp, and let this be unit step. Okay, so for this, C of t is equal to t minus capital T plus t into the e to the power minus t by capital T. Here this response was is equal to C of t is equal to 1 minus e to the power minus t by capital T. And for unit impulse, it was 1 by T e raised to the minus T by capital T. So this is the response of a first order system for unit ramp, unit step, and unit impulse. Now we know that the unit step, that is u of t, is equal to the derivative of ramp function, and the impulse response delta of t is nothing but the derivative of d by dt of the step response, that is u of t. So we know this relation. So when we derive ramp function, we get unit step response, sorry, unit step function, and when we derive unit step, we get impulse function. So the similar relation can be observed in the responses also. So you can see that when you, this is C of t, so this is impulse, I'll name it as Ci, step, I'll name it as Cs of t, and this Cu. So you can find that when we derive ramp, now this is the ramp one, so the derivative of unit ramp response, that is Cu of t, is nothing but Cs of t. You can find when you derive this one, t minus capital T plus t into e to the power minus t by t. So when you derive this function, so what we get is Cs of t, that is unit step response. Similarly, the derive when we derive Cs of t, so when we derive this function, what we get is Ci of t. So you can see that you have two responses, and you know that one response is a derivative of another. That the response of the derivative of the input signal can be obtained by differentiating the response of the system to the original signal. It means that, to put in simple words, you have a function f of t. Consider a input signal, sorry, not input signal r of t. The response of this, the response for this signal, the response for this input signal is C1 of t. And we have another input signal. We have another input signal, x of t, such that this x of t is a derivative of r of t. So then the response for signal, the response for signal x of t, that is C2 of t, will be equal to the derivative of C1 of t. This is how we can use the derivation to get the response of the signal, which is the derivative of the original signal. I'll repeat. The response to the derivative of an input signal can be obtained by differentiating the response of the system to the original signal. So this is possible only in case of linear time invariant system. Now this statement or this result, or I can say this um, observation, is only relevant for LTI system. If you go for linear time varying system or non-linear system, this statement will no longer hold good. Only for linear time invariant system we can come up with this conclusion. Thank you.